Hello, everyone. Today, we're continuing with the topic of functions. Let's start by defining a simple function. We're creating a function called greet. This function takes one parameter and uses it inside the body. Notice that by default, the parameter name is inferred as any, so we explicitly set its type to string. We'll also define the return type of the function. This part specifies the parameter's type, and this one defines the type of the value the function returns. Now let's call this function with an argument and log the result to the console. As you know, we use the npxtsc command to transpile the code. And in the console, we see the output. Hello, Alice. Now let's create a new function that dynamically returns the current year. We use newDate, getFullYear for that. Technically, we could define a return type for this function, but let's skip that for now. Let's go back to the console and check both the value returned by the function and its type. We compile the code again and check the result. As you can see, even though we didn't explicitly define a return type, TypeScript is able to infer it automatically. Now we're defining a function that doesn't return any value. Inside the function, we simply write console log hello world. So what should we write as the return type for a function that doesn't return anything? In such cases, we use the void keyword to indicate that the function has no return value. Let's call the function. Let's compile the code again and check the result in the console. As you can see, it runs without any issues. Now let's take a look at optional parameters. We are creating a new function. In this SumNumbers function, we have 3 parameters, all of which are number type. The function returns the sum of 3 numbers. Let's call the function. As you can see, when we call the function with 3 arguments, no problem occurs. But what if we only pass 2 arguments? It throws an error saying that it expects 3 arguments. So, how can we call this function with 2 arguments? We use a question mark to make the C parameter optional. Now the error in the console log line is gone, but since the value of C will be undefined, there is still an error, so we use the OR operator to say that if it's not provided, we simply use 0 by default in the expression. Let's compile the code again and check the result in the console. So when we call the function with just 2 arguments, it still works and returns the correct result. Next, we have default parameters. We're defining a new function called multiplyNumbers. This function takes 3 parameters and returns the result of multiplying them together. Let's call the function. When we pass only 1 argument, as you can see, it throws an error because it's expecting 3 arguments. To avoid this, we assign default values to the parameters like this. In this multiplyNumbers function, the second and third parameters have default values of 1. This means if we don't pass values for them, 1 will be used automatically. And now, as you can see, the error is gone. Let's test it with different combinations of arguments to see how the result changes. We compile the code again and check the result. In the first case, both B and C take the default value of 1, so the result is 5. In the second call, C defaults to 1, while A is 5 and B is 7, so we get 5, 7, 1, 35. And in the third example, all three arguments are provided, so we get the full multiplication result, which is 70. Now let's explore rest parameters. Here, we're defining a function called SumAllNumbers. This function will accept an unknown number of arguments, so we use the rest operator like this: 3 dots numbers. We also need to define the type of the parameter. Since it receives multiple numeric values, as an array, we write the type as number square brackets. To calculate the total of all the numbers passed to the function, we use the reduce method. Inside reduce, we provide two parameters: total and current value. The total represents the running sum at each step, and current value represents the current element coming from the array. We set the initial value of total to 0. And each element from the array will be added to the total sequentially. Now let's call the function. We pass 4 arguments, and the rest operator collects them into an array. We compile the code again and check the result. Now how it works. We set the initial value of total to 0. We pass 4 arguments, and the rest operator collects them into an array. Then, one by one, each value is passed to current value, while total accumulates the sum. In the end, we get the total result, which is 37. As you can see, it works perfectly with multiple values. Now let's take a look at how arrow functions are used. We're defining a new function called multiplyNumbersArrow. This function takes 3 parameters, and all of them are of type number. Since it's an arrow function, we don't need to use the return keyword. It automatically returns the result of the expression. The function simply returns the product of the 3 parameters. To handle cases where only one argument is passed, we assign default values of 1 to both B and C. Let's test it with 1, 2, and 3 arguments. Let's compile the code again and check the result in the console. As you can see, in all 3 cases, the function runs smoothly and returns the correct result. Arrow functions in TypeScript are used just like this. Here we used an arrow function to achieve the same multiplication logic. This version is more concise, but it works the same as a regular function. All right, now we're moving on to a new topic: shared types. We're defining a new function called wrapInArray. This function takes a parameter that's expected to be an array, and it returns that value. So we write it like this. Then we call the function, but instead of passing an array, we pass a string. As a result, we get an error, because the function is expecting an array. What we want is for the parameter to sometimes accept a string and sometimes an array. In other words, we want both types to be valid. So how can we do that? Just like we've done before, we can use a union type. We add a vertical bar, also known as the pipe symbol, to define a union of types. In this wrap-in-array function, we accept either a single string or an array of strings. Now, since we want the return value to always be an array, we need to write some logic. If the input is already an array, there's nothing to change. But if it's just a string, we need to wrap it inside an array using a condition. If the input is just a string, we wrap it inside an array. Otherwise, we return the array as is. We compile the code again and check the result. When we check in the console, we see that it returns an array with a single element. We can also add a return type explicitly if we want to make it more clear. This is how we can write a function that accepts multiple types of input. This is a great example of using union types in TypeScript. Now let's look at a special return type, never. We're defining a new function called throw_error. This function takes a message as a parameter and uses it as the error message in a newly created error. A function returning never cannot have a reachable endpoint. This throw_error function never returns a value. It immediately throws an error. TypeScript recognizes this behavior and assigns it the never type. This is how we define functions that are meant to throw errors. We give them a never return type. Here's another case that results in a never return type, an infinite loop. We define another function called infinite loop, and inside it, we write a while loop that runs forever. The infinite loop function keeps running endlessly and never reaches an endpoint. So TypeScript also infers its return type as never. In general, we use the never type for functions that either throw errors or never terminate. And with that, we've reached the end of today's lesson. In this lesson, we covered how functions work in TypeScript. We started with basic function declarations, then explored return types, optional and default parameters, rest parameters, arrow functions, union types, and finally, the special never return type. Understanding how to type functions properly helps us write safer and more predictable code. TypeScript gives us powerful tools to make our code both flexible and robust. That's all for today. Great job following along. Don't forget to practice what you've learned, and I'll see you in the next lesson.